Good afternoon, good morning, good evening, whatever it is you're watching, or even good night, right? Today's topic is Ionic Bond, section 8.6, and of course, this all comes from your CK12 packet. So, hello there, guys. Hope you're doing well. And we're going to start off today's lecture by talking and introducing um, or asking the question, does the sea really have salt in it? Who's going to help with the introduction?
We can get common table salt from several sources. It can be mined in the solid form in salt mines or found as a solid in the tablet. We can also get salt from the ocean, but it really does not exist as salt when in solution. The sodium ions and chloride ions are dissolved but not combined into a structure until all the water is.
Thank you. Right. So, according to this paragraph, it's saying that salt isn't necessarily salt when it's in solution. Okay. Water is one of those special compounds that will break apart ionic compounds, and salt is definitely an ionic compound. So what water molecules do is they will get in between the chlorine and the sodium and break each element into its ionic form. Okay. And that's just a special ability about water. So if you really want salt out of seawater, you're going to have to boil off or remove completely the water in the solution. Once you do that, then you'll get that salt ionic compound back. And most rocks and minerals that make up the Earth's crust are composed of positive and negative ions that are held together by ionic bonding. Now, what's an ionic compound, Miss? Well, an ionic compound is an electrically neutral compound consisting of positive and negative ions. And remember, those ions, we're talking about cations and anions. Always remember, and I'm going to emphasize this again, cations lose electrons, right? Cations always lose electrons. And when they lose electrons, they get what's known as a positive charge. And a reminder that anions do the opposite of a cation. They gain the lost electrons from these cations. And anytime an element does this, you get a negatively charged anion. Okay, so make sure you keep that in mind because it will come up. You are very familiar with some ionic compounds. Table salt, right? Sodium chloride, NaCl. That is an ionic compound. We love it on our tacos. Is it good for us? Not so much, but it's really tasty, especially on our tacos. You got to remember that the sodium chloride compound, ionic compound, is composed, or a sodium crystal consists of equal number of positive sodium ions, which is Na+1, and negative chloride anions, which is chlorine -1. Okay, so that is your sodium chloride compound. You always got one of each, one sodium for every one chlorine. All right, let me just move that up here. Ionic bonds. Ionic bonds, you have to remember, if you ever played with a magnet, you know if you have the opposite ends of the magnet together, right? You have that positive end along with that negative end. Those magnets are going to come together right away. The same thing happens with ionic compounds. If you have a cation like sodium And an anion like chlorine, right? The sodium has given one electron to chlorine. You're going to have oppositely charged ions. That's very similar to these oppositely charged particles that we're talking about. Okay? These oppositely charged ions will have what's known as a electrostatic force that's going to bring them together and form this bond that we're talking about. Okay? An ionic bond is an electrostatic force that holds ions together in an ionic compound. The strength of the ionic bond, it depends on certain quantities of electrons lost. The more electrons you have, the stronger your ionic bond will be. It also inversely is dependent on the distance between the charged particles. For example, if you have a cation like with a +2 charge, like all the group 2 elements, right? Anytime you have a group 2 element, you're going to probably lose those electrons and you're going to be left with a +2 charge. These groups of elements, group 2, make stronger ionic bonds than a cation with a +1 charge, right? They're comparing group 1 alkali metals to group 2 alkali earth metals. Alkali metals, group 1, lose 1 electron and they create a weaker ionic bond with an anion. In comparison to group 2, the alkali earth, those are much better cations when you're trying to form strong ionic bonds. And also take into consideration, if you have a large ion, right? We're talking about the bottom half of the periodic table. This is where your elements start to get bigger and bigger and bigger, mostly because you got more and more electrons, right? Now, the bigger the ion, it will make a weaker ionic bond because you have a very large distance between the electrons of the other element and the nucleus and your nucleus, right? Remember, the further you are from each other, and we're talking about the electrons over here and the nucleus for over here, the further and further you are, right, the bigger and bigger the ion is, the weaker your ionic bond will become. And here you have an example. You have 3 pictures of the formation of an ionic bond. In picture A, you have the actual formation of the ions, right? You have your sodium element or atom. You have your chlorine atom, right? This is before anything has been lost or gained. Sodium has 1 valence electron in its outer shell. Chlorine has 7 valence electrons. So sodium is like, I'm looking for somebody. I need to get rid of this 1 electron. Anybody out there need an electron? And then you're going to see chlorine pop its little head up, right? Over here, I'm chlorine. I only have 7 valence electrons. I'm looking for 1 more. You're going to see that sodium is going to want to donate that 1 valence electron that it has to chlorine, and that will end up with picture B where you have that sodium ion now, right? Ion means that you have either lost or gained. In this case for sodium, it lost 1 electron. For chlorine has changed. Chlorine is now a chloride ion. It has gained 1 extra electron so that it can make octet. And once you have that plus and negative charge, well, you're going to have that electrostatic attraction between the two, and it's going to form that ionic compound that we're talking about. And you can see it here in picture C. Any questions? Any questions? All right, I don't see any questions. All right. Here you have 2 questions. Number 1, you have a true and false. And number 2, you got to fill in the blank. All right. I want you guys to try it. Number 1, true or false? An ionic bond is the electromagnetic force that holds ions together in an ionic bond. Number 2, fill in the blank. A larger ion makes a blank ionic bond because of the greater distance between electrons and the nucleus of the other ion or the other element, right? What do you think, guys? I'm going to give you some thinking time. I had some people come in a little late. So Yaslin, Efrain, and Jose. Yaslin, Efrain. I'm going to give you some thinking time. And then Miss Hania. No responses, guys. Come on. True or false? That's an easy question. What do you think? You have a 50% chance of getting it right. According to what we discussed right now, does an ionic bond use electromagnetic forces to hold these ions together? True or false? False. Mario says false. Okay. Anybody else want to try it out? Anybody else want to try it out? Oscar, what do you think? True or false? Yeah, Alexia, what do you think? True or false for this question? Gabby, what do you think, Gabby? ¿Qué piensas? Irvin, can I get a true or false from you? What do you think? An ionic bond is the electromagnetic force that holds ions together within an ionic compound. True or false, Irvin, Oscar, Alexia, Jocelyn? What do you think? I got a response. All right, this person says it's true. Nobody else posted. All right, I got a tie. I got one person who says that it's false. Another person says that it's true. Oh, but here comes Irvin. Irvin is saying that it's false. Why do you say that it's false, guys? Mario and Irvin? What do you think makes this statement false? Just throw out something. What do you think? What tells you what does your gut say? What does your gut say about this sentence or this statement? What makes it false? What do you think, Irvin? Mr. Irvin? No? Either way, Mario, Irvin, you are correct. It is a false statement. Ionic bonds don't use electromagnetic forces. They use electrostatic forces. Okay? And you can see it in the last slide. It says here in bold in the second sentence, this attractive force is often referred to as an electrostatic force. Okay? Mario Irvin, good job. Now, fill in the blank. A larger ion makes a blank ionic bond because of the greater distance between its electrons and the nucleus of the oppositely charged ions. What do you think goes in the blank? What do you think, Oscar? Jocelyn, Arlette, what do you think goes in the blank? And I'm going to give you some options. Let me give you some options. All right. I put in some options in the chat. What do you think, people? What do you think? I've given you some options in the chat. A or B? A larger ion makes a stronger ionic bond. A larger ion makes a weaker ionic bond. What do you think? What did we say? What did we do? What did we say in our discussion? All right. Oscar's saying stronger. Did anybody post here? Let me see. Oh. What do you think, Alexia? Mario, Irvin, Arlette, Kevin, Gabby? Which one goes in the blank? I don't see anything, guys. Come on. All right. Remember, if you are a large ion, that means that you have a very large distance between you and the other element. That always makes weak bonds. Not stronger, Oscar. Sorry.
Hey guys, what's up? So I am super.
Why did I do that? I already have it open.
Hi, it's Mr. Anderson, and this is Chemistry Essential Video 20. It's on ionic bonding. Remember, ionic bonding differs from covalent bonding. Covalent bonding, they're sharing the electrons. In ionic bonding, what you're doing is you're transferring the electron from one atom to another. And so the quintessential example is sodium chloride. So sodium, here's its electron configuration, has one valence electron, and chlorine is going to have 7. And so if we look at their electron configuration, if we can actually transfer that electron from sodium to chlorine, then we get to this electron configuration that is a noble gas. It's going to be very stable. And so what we get is a sodium ion and a chlorine ion. And so the sodium ion, since it's lost an electron, we call that a cation ion. It has a positive charge, and chlorine is going to be a negative charge. And the way I remember this, it's a little bit silly, but if you take that sodium ion, a cation ion, if you think of a cat has paws, and that means it's positive. Sorry about that, it's a little bit lame, but it's a good way to remember it. And so ionic bond is going to be between ions. It's a connection between ions. And so we're going to have a cation and an anion. Cation is positive. That means they've lost an electron, and anions are going to be negative. And so what they form is something called an ionic solid. Now, how well that solid is held together is based on Coulomb's law. Remember, if we have a larger charge, there's going to be a larger attraction between those two molecules, or atoms in this case. And then the greater the distance is, the less the force is. And so if we have a really small ion and a large charge, we're going to have a stronger interaction. So it's important to kind of remember those two things. And so here's sodium chloride. Sodium chloride is going to be all of our sodium ions. Those are going to be purple, which have a positive charge. And they're going to organize themselves in this real crystalline, nice solid. It's really high melting point, high boiling point. A super easy way to break it apart is with water, but it's going to be an incredibly stable kind of a molecule. And so what determines the stability, how well it's held together, is simply Coulomb's law. Coulomb's law, remember, if we have the same charge, there's going to be repulsion. If we have opposite charges, there's going to be attraction. But if we look at the formula, the bigger those charges are, the greater that attraction is. And the bigger the distance, since this is the radius right here, the less that attraction is going to be. So let's throw sodium chloride up here. Sodium, which is going to be the cation, chlorine, which is going to be the anion. And then there's something called lattice energy, which just is a way to measure how well this lattice is held together. So if we look at this right here, I mean, make a prediction. What do you think is going to happen when we move this from sodium chloride to sodium fluoride? Well, in each of these diagrams here, sodium is going to be this little purple sphere, and I try to keep that about the same size. But let's look at fluorine now. As we move to fluorine, can you see that that fluorine ion is going to be smaller? And since it's smaller, our lattice energy is going to increase because those ions are closer together. So let's go back to sodium chloride. What do you think is going to happen when we make sodium bromide? Well, the purple sodium cation is going to stay the same, but now since we've increased the size of that atom, we've decrease this lattice energy.
So did you see how you had it at chlorine, right? It was at 780 something, right? It goes up and it starts to form bonds with fluorine, and all of a sudden that strength between the two elements jumps up. It gets stronger. Why? Because those electrons and that nucleus are closer together. The closer they are, the stronger the ionic bond, right? But as you go further down the periodic table, you got to remember your ions are getting bigger and bigger and bigger. That is going to create a larger distance between your electrons and the nucleus of the opposite elements, making what's known as a weaker ionic bond. And you're going to see that in the numbers that he's going to show you.
Same thing as we go to sodium iodide.
Look at that, 682. When it was bonded to fluorine, it was at 1,000 something. And then it went to 780. And then it went to 760 or whatever it was. And look, it's lowering even further, 682. That's a big difference.
And so as it gets bigger, that distance between the two, just due to Coulomb's law, we're going to see a decrease in that energy between them.
And you can actually use this formula and calculate that energy.
But what's the other thing that can affect it is the charge. And so if we run sodium chloride versus barium oxide, which is going to have a totally different charge, you can see that there's a great difference between those lattice energies. In other words, as we increase the charges, we increase that ionic bond between the two atoms. And so did you learn this to connect the microscopic structure to the macroscopic properties? It's simple. It's Coulomb's law. The greater the charge is and the smaller the distance between the ions, the greater the bond strength. And I hope it's
all right, thank you, sir. Okay, let's restart that for the next class and let's continue our presentation. All right, the last major topic for today, electron dot diagrams and the ionic bond. We're going to be using sodium chloride as an example to demonstrate the nature of the ionic bond and how it forms. And you have a very nice picture at the bottom that goes along with this that describes this what's happening, right? And that shows you. As you know, sodium is a metal. Metals have a tendency to lose electrons. In this case, sodium is in group 1, so it's going to lose that one valence electron. And it's going to change into what's known as a sodium ion, which is a cation. Chlorine, a nonmetals have a tendency to gain electrons. In this case, chlorine already has 7. It only needs to just gain one more. And it's going to gain it from sodium, as you can see in the picture below. Both achieve a noble gas electron configuration when they lose and gain, right? Once they become cations and anions, both have a complete octet in that outer energy level. However, electrons cannot simply be lost to nowhere in particular, right? Yesterday and on Tuesday, when we were talking about, this atom is going to gain 2 electrons, and this atom is going to lose 1 electron. Well, they don't just come from, electrons are not just floating around in the air. That doesn't happen. Electrons have to be associated with certain elements, right? Or with all elements. And so you have to have somebody willing to give up electrons and somebody willing to gain electrons for ionic bonds to occur. A more accurate way to describe what is happening is that a single electron transfers from sodium to chlorine, as shown below. So this is what we're talking about. You cannot just let me just go and get an electron so I can become an anion. No. Or, hey, let me just lose an electron to the atmosphere so that I can become a cation. No, that does not happen. You have to have elements associated so that this exchange or this transfer can occur. For sodium, you got a 1 valence electron, so you're going to see just 1 dot. Chlorine has 7 valence electrons, right? It's from group 17. And you can see those 7 dots surrounding the symbol for chlorine. And the red arrow shows the movement or the transfer of that 1 valence electron from sodium to chlorine. And you have your complete ionic compound on the right, where sodium has that +1 charge, chlorine has that -1 charge, and you have this nice ionic compound. The ionic bond is the attraction of the sodium +1 ion for the chlorine -1 ion. It is conventional to show the cation without dots around the symbol to emphasize that the original energy level that contained the valence electron is now empty. The anion is now shown with a complete octet of electrons. So, for the most part, we know that sodium loses that 1 electron, so it can use the lower energy level that already has the octet of electrons. But you don't need to show it for electron dot diagrams. The only thing you need to show is valence, okay? And if you had 2 valence electrons and you've donated them, you're not going to draw that other level that has your octet. You're just going to show, okay, it lost, it's going to have a +2 charge. We know in our heads, right? We know in our minds that there is another principal energy level below that valence shell that has the octet of electrons. Okay, so we don't have to show it, we know it's there. But since chlorine had 7, it gained 1, we will show that valence shell of electrons that's full for the element, for the anion chlorine. For a compound, you have a second example. You're talking about, in this example, you have magnesium chloride. It's not quite as simple as it is for sodium chloride. Why? Because magnesium has 2 valence electrons, right? It's part of that group 2 alkali earth metal. So you're going to have to bring in a second chlorine, right? You cannot lose both of those valence electrons that magnesium has to 1 chlorine, right? It only needs 1. What's going to happen to the other? You're going to have to bring in a second chlorine to take away that second electron from magnesium. And you're going to have the ionic compound, magnesium chloride, have 2 chlorines and 1 magnesium. And you can see that nice compound right here in the picture below. Any questions? Any questions? Is anybody confused by the electron dot diagram of an ionic compound? I don't see anything in the chat, but I want to give you a minute to think about it. Okay, I don't see anything. All right. All right, you got a very simple, this is your last Pear Deck question before we close out our lecture. It says here, how many electrons are lost and gained by each element in the formation of this ionic compound? And you guys were really good at this yesterday, so I'm hoping that you can pick up on this today again. All right. So it's also is asking you to include the element symbol and the charge. All right. So let's analyze this picture. How many, and we're talking about calcium, Ca, calcium, Ca. How many electrons do you see here for calcium? How many electrons do you see here, Mario? Oscar? 2, right? Okay. How many does it have now? On the right, 0. So remember, the number of electrons that is lost is your charge. So in this case, we lost 2. But my question, what is the symbol for that charge? What is the symbol for that charge? Is it a plus sign or is it a negative sign? Be careful, Oscar. Remember, I showed you this Jamboard. What happens? Are you a cation if you have lost electrons, or are you an anion when you have gained electrons? What is going to be the case for this calcium? You had two, right? You had two, and then you had none. Very good. Very good. Yes, that is correct. It's going to be positive, definitely. All right. So the first one will have Ca with a +2 charge. Can you type that in the chat for me, Oscar? Or can somebody type it on Pear Deck? That would be nicer, but I'll take the chat instead. So Ca with a +2 charge, Oscar. Can you show me that in the chat? Calcium with that +2 charge that you described? Very good, sir. Very good. What about chlorine, Oscar? What do you think? What do you think, Alexia, Mario, Irvin? What do you think is going to be the charge for chlorine? Look at what you have on the left, right here. Look at what you have here. Look at what you have here. How many or what happened to this chlorine? Okay, why negative? Why negative, Oscar? That is correct. Because it gained. How many did it gain in this case? 1. So what's my charge? What's my symbol and my charge for this element? Or ion, right? Because it's now an ion. Give me the symbol and the charge. The symbol and the charge. What's the symbol and the charge for this element? There it is. Plus? I don't know about plus. Let's go back over here, sir. What does it say here? You're telling me it gained. I said yes. Okay, so what's the correct answer? Symbol and charge. I want to see the correct one. The symbol and the correct charge. That is it. That's what I was looking for, Oscar. Very good. Cl -1. Very, very good. Okay. Turn that off. In summary, an ionic compound contains positive and negative ions. An ionic bond is electrostatic in nature. And the third point of this lecture is that electron dot diagrams can be used to illustrate the electron movement and ion formation. Your review questions, very simple. What is an ionic compound? What is an ionic bond? And which cation, Na+1 or Ca +2, would form a stronger ionic bond with Cl? All right. Thank you so much for your attention.